Today we are starting with new topics, that's adsorption isotherm. What is adsorption isotherms? Means adsorption isotherms adsorptions absorptions isotherm means these variations these variations in the amount of gas, adsorb adsorb absorbed by the adsorbent with pressure sure at a constant temperatures can be expressed by mean of curve term as adsorptions. What is adsorption isotherms? These variations in the amount of gas adsorbed by the adsorbent with pressures at a constant temperatures can be expressed by mean of a curve term as adsorptions. Let's see how it happens. This is the solids. Solid. There are so many gases are present. In the environment. If we put pressures, in these directions, the adsorptions of gases on solid surface take place. Here, solid is adsorbent, and these gas particles are adsorbate. Here, this is the solid. If this is the gas molecules are present in environment, if we put pressure in this direction, this gas molecule will adsorb on the surface of a solids, and adsorption occurs here at constant temperatures. There's no involutions of no change of temperatures here at a constant temperatures. Here extent of gas adsorb on solid surface is directly proportional to pressure. No involutions of temperatures means at a constant temperatures, means the temperature is constant. If we understand what is isotherms, iso means same and therm means temperatures. At means at same temperatures. There is also same solid. This is the solids, and these gas molecules are adsorbed at same temperatures. There are no changing of temperatures. We will understand better with the help of graph. The terms with the help of graph, if we graph. But first we see this gas molecules is a solids of mass m, and this how many gas molecules was adsorbed on the solid is the value is x. The value is x. X is the value how many molecules of gas adsorbed on the surface of a solid, means quantity quantity of adsorptions adsorbed is x is the quantity quantity of adsorbate quantity of adsorbate. We will understand this isotherm better with the help of graph. The help of graph. If we plot graph, this is the x-axis and this is the y-axis. In x-axis we will plot x by m, where x is the value, is the quantity of adsorbate, and here m is the mass of adsorbent, and here we will see the pressures. Temperature is constant. At constant temperature. When we put pressures, instantly we will see in a linearly, but when we put some more pressures, the graph will look like, and when we put more higher pressures, the graph will be like this. We see this part is going increasing when pressure is increasing, also the value of adsorptions is also increasing, but after this point, when we put pressures, the adsorptions is slowly decreasing. At the speed of adsorptions slowly decreasing at this point, from this to this point, and after we put more pressures, then adsorption is not increase, it going constant, is not accelerate. Adsorption is not accelerate. Okay, and accelerate. This is when pressure is low. Graph will look like this. Low pressure is look like this. When pressure increase, at same times adsorption is increasing. There is a slope. This is the x by m is directly proportional to the p, and this is the intermediate phase. Intermediate phase where the value of x by m directly proportional to the p raised to 1 by n. When pressure is high, x of m is directly proportional to p of power 0. This point is the point we seeing. This is the saturation point. Saturation pressure. After this point, no more adsorption is taking place. No more adsorption is taking place. We see in this graph at very low pressures, the value of x by m is directly proportional to the p. In case x by m is equal to k, here k is the constant. Okay, k is the pressure constant. Pressure constant. Okay, at very high pressure, at very high pressure, sure, means in this we is talking about this part. At very high pressure, value of x by m directly proportional to the p the power 0. X by m is equal to k. And at intermediate phase, in this we are now talking about this part. At intermediate phase, value of x by m is between 0, more than 0, and less than 1. This is the intermediate phase. At intermediate pressures, at intermediate pressure, the value of x by m is equal to k raised to power 1 by n. Here value of 1 by n is value of 1 by n depends upon nature of solute. Means solute is adsorbate, and solvent means adsorbent. Value of 1 by n depends upon nature of adsorbent and adsorbent. We got equations at interface. We got intermediate phase. We got equations. X by m is equal to k p raised to power 1 by n. We are plotting Freundlich's adsorption isotherms. Freundlich adsorption isotherm. If we put these equations, if we take log on both sides, if we take log on both sides, equation will look like this. Log x by m is equal to log k p raised to power 1 by n. Going to be same. X by m is equal to log k plus log p raised to power 1 by n. Again, this part will be remaining same. This part will also remaining same, but 1 by n log p. Okay, these equations will look like these equations. Y is equal to mx plus c. We got our general equations. Y is equal to mx plus c. We will plot graph. This log x by m we will show on y-axis, and this will on log p c on x-axis. If we plot graph of Freundlich adsorptions is log x by m, and here is log p. Okay, adsorption isotherm will look like this. and this is the intercept. This is the intercept. The intercept, and intercept, this is the value of log k, and this is the slope, value of 1 by n, value of 1 by n, the value of 1 by n. The slope of the straight line is 1 by n, and intercept is log k. This adsorption isotherm is successful for at interface phase, means at medium pressures and also at lower pressures, but it's fail at high pressures, means have some limitations. Is very at very high temperatures, this adsorption isotherms not followed. And second limitation is not following chemical adsorptions. It's not follow chemical adsorption. It's not useful for chemical adsorptions. These two are limitations of Freundlich adsorptions isotherms. If you like this video, then share, like and subscribe. Thank you.